Imagine staring into a void so profound, so impossibly distant, that it holds the very first echoes of creation. A time when the universe was just a baby, only whispers away from the Big Bang itself. For centuries, this was an unreachable mystery, hidden behind veils of cosmic dust and the limitations of light. But now, humanity possesses a new kind of eye, a golden gaze that pierces through the darkness. The James Webb Space Telescope is not just a machine, it is our ultimate time machine, revealing secrets that were once locked away forever. Prepare to journey to the dawn of everything you know. This is not merely a scientific instrument. The James Webb Space Telescope, or JWST, is a triumph of human ingenuity and sheer audacity. It is the most powerful telescope ever built, a technological marvel launched with the hopes of billions riding on its precise, unfolding mirrors. Its true power lies in its infrared vision. Unlike the iconic Hubble, which primarily sees invisible light, Webb sees in the infrared spectrum. This allows it to penetrate thick clouds of cosmic dust and gas, revealing stars and galaxies that were utterly hidden from Hubble's view. It is like being handed a map to a treasure trove previously obscured by a dense fog. The journey to create and launch JWST was fraught with challenges, decades of painstaking work and billions of dollars. There were technical hurdles that seemed insurmountable. The sheer complexity of its design, its delicate sunshield the size of a tennis court, and the intricate choreography required for its deployment millions of miles from Earth. Every single step carried immense risk. The world held its breath during its launch, its deployment, and the agonizing months of calibration. Would this incredibly expensive, incredibly complex machine actually work? The suspense was unbearable. Then came the first images, and the universe as we thought we knew it changed forever. The initial revelations were breathtaking, almost unbelievable. Webb delivered not just pretty pictures but profound scientific insights. It showed us structures, light from times so ancient they rewrote textbooks overnight. The sense of awe, that chilling realization of our tiny place in a vast ancient cosmos, was overwhelming. We were seeing the impossible, gazing back through billions of years of cosmic history, witnessing moments that were previously only theoretical. One of JWST's most profound achievements is its ability to unveil the early universe. It has delivered stunning images that reveal the very first galaxies ever formed, emerging just after the Big Bang itself. These are not fully formed, elegant spirals. They are chaotic, vibrant, almost primordial structures, furiously forming stars. We are witnessing the cosmic dawn, the moment when the first stars ignited, pulling the universe out of its dark ages. It is like seeing the first flickering flames in a universe that was once entirely without light. The implications of these observations are nothing short of revolutionary. For decades, astronomers had theoretical models of what the first galaxy should look like. But Webb's images are challenging those very theories. These early galaxies appear surprisingly massive. They seem more mature than our models predicted. This creates a genuine scientific mystery. Is the universe's early evolution, the speed at which it formed complex structures, far more rapid than we thought? This discrepancy forces scientists to re-examine their fundamental understanding of how the cosmos evolved from its earliest moments. The speed of formation suggested by these discoveries is astounding. It's as if the universe sprang to life faster, evolving at an accelerated pace in its infancy. This hints at unknown processes, perhaps even entirely new physics, that govern the cosmos in its turbulent youth. The more we learn, the more questions arise. What hidden factors allowed these colossal structures to coalesce so quickly? The answers could redefine our cosmic origins, painting a far more dynamic and energetic picture of the universe's initial years. The search for these answers is now a global scientific imperative, fueled by Webb's startling data. Beyond the earliest light, JWST is also peering into distant, more evolved galaxies, offering stunning, intricate details that were previously invisible. These are cosmic islands, each containing billions of stars, vast nebulae, and swirling cosmic dust. Webb's infrared eyes pierce through the dust lanes, revealing hidden star-forming regions, the birthplaces of new suns. These images are not just beautiful, they are time capsules, each one holding clues about the universe's grand narrative. We are witnessing billions of years of cosmic evolution, condensed into a single frame. These detailed images reveal crucial information about the composition, age, and evolutionary pathways of these distant galaxies. We can see how they interact, how they merge, and how they grow. It's a violent, beautiful cosmic dance, happening on scales almost beyond human comprehension. These findings are directly connecting to our understanding of the universe's overall structure and its colossal history. They paint a picture of a dynamic cosmos, constantly evolving, constantly reshaping itself. The universe is not static. It is alive, changing, breathing. The universe is organized in a vast, intricate network, often called the cosmic web. It consists of enormous filaments of galaxies and dark matter, stretching for billions of light-years, separated by colossal voids of empty space. JWST's observations of distant galaxies help us map this grand structure with unprecedented precision. We are seeing how galaxies cluster together, pulled by the invisible hand of gravity, forming the largest structures in the cosmos. It's like seeing the skeletal framework of the universe itself, an immense, interconnected sculpture crafted by unimaginable forces. The power of infrared light cannot be overstated. It is the key to unlocking these visible truths from the invisible. It allows Webb to pierce through the opaque curtains of dust and gas that shroud many celestial objects. This reveals hidden stars and phenomena that would otherwise remain forever concealed from our optical telescopes. Imagine trying to see through a dense fog and suddenly you have night vision goggles. That is the transformative power of Webb's infrared capabilities. It is showing us a universe that was always there but we just couldn't see it. These vast, intricate structures, these colossal galaxies, are not just shaped by visible matter. They are profoundly influenced by forces we still barely understand: dark matter and dark energy. Webb's observations, by revealing the distribution and evolution of galaxies, provide critical clues about these mysterious, invisible components that make up the vast majority of our universe. What are they? How do they work? The more we see, the more questions arise, building an intense intrigue around the invisible scaffold that holds the cosmos together. The universe is revealing its secrets, piece by unsettling piece. But if we can peer back to the very dawn of galaxies, if we can map the invisible structures of the universe, then what about the question that truly captivates us all? What about life beyond Earth? If stars are forming everywhere, if galaxies are teeming with billions upon billions of suns, then surely somewhere life must exist. This brings us to perhaps the most thrilling aspect of Webb's mission, a quest that could redefine humanity's place in the universe. This powerful eye in the sky is not just looking at dead stars and gas clouds. It is actively searching for the faint whispers of life. The question that truly electrifies human curiosity remains: are we alone? If we can peer back to the dawn of galaxies, if we can map the invisible structures of the universe, then surely somewhere life must exist. This brings us to perhaps the most thrilling aspect of Webb's mission, a quest that could redefine humanity's place in the universe. This powerful eye in the sky is not just looking at dead stars and gas clouds. It is actively searching for the faint whispers of life. Its groundbreaking ability to detect and analyze exoplanet atmospheres is truly revolutionary. Webb uses a technique called transit spectroscopy. As an exoplanet passes in front of its host star, Webb can analyze the starlight filtered through the planet's atmosphere. Different molecules absorb light at different wavelengths. This allows the telescope to act like a cosmic detective, identifying the chemical fingerprints of gases like water vapor, methane, and carbon dioxide. Imagine we are not just seeing these distant worlds, we are smelling their air, searching for the telltale signs of conditions that might support life. This is a level of detail previously confined to science fiction. The direct detection of these molecules is a monumental leap. Finding water vapor is a crucial step, as liquid water is considered essential for life as we know it. But the real game changer would be detecting a combination of gases that, on Earth, are only produced by living organisms, what scientists call biosignatures. Imagine finding significant amounts of oxygen and methane together in an exoplanet's atmosphere. This combination is highly unstable unless continuously replenished by biological processes. Such a discovery would send shockwaves across the globe, fundamentally altering our understanding of life's prevalence in the cosmos. Every new exoplanet observation by Webb adds another piece to this colossal puzzle. It informs our understanding of habitability. We learn about the temperature ranges, the atmospheric pressures, the presence of stable conditions that could allow liquid water to persist on a planet's surface. It's a painstaking process, but each data point brings us closer to identifying those precious few worlds that might truly harbor life. The universe is vast beyond measure, but the tools to seek out cosmic companions are finally in our hands. The emotional weight of finding definitive evidence of extraterrestrial life would be staggering. It would force humanity to confront its own uniqueness, or perhaps, its lack thereof. It would redefine our origin stories, our religions, our philosophies. The search for life is no longer confined to speculation. It is a tangible, scientific pursuit, with Webb leading the charge. Consider the Drake equation, a probabilistic argument used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. For decades, many of its variables were pure guesswork. But with Webb's insights into exoplanet prevalence and atmospheric composition, we are now able to put real data into some of those previously unknown factors. This brings renewed relevance and urgency to the equation. We are narrowing down the possibilities, transforming wild speculation into informed scientific inquiry. The cosmic silence might not be so silent after all. Yet, even with the unprecedented capabilities of the James Webb Space Telescope, directly proving life is an incredibly difficult, almost insurmountable task. The detection of biosignatures is a powerful hint, a tantalizing clue, but it is not definitive proof. There could be unknown geological or chemical processes that mimic these signatures. The vast distances involved mean that every data point is incredibly faint, susceptible to noise and misinterpretation. We are looking for a needle in a cosmic haystack, and even if we find a thread, proving it came from life is another challenge entirely. Furthermore, atmospheric complexities can deceive us. A planet's atmosphere can be layered, with different chemical compositions at various altitudes. Clouds can obscure signals. Stellar flares from the host star can interfere with observations. These are not simple, clean detections. They require sophisticated modeling, cross-referencing, and immense computational power to interpret. Webb opens doors, yes, but it doesn't give us immediate, easy answers. It presents us with more profound questions, pushing the boundaries of our scientific methods and our patience. The universe guards its greatest secrets fiercely. So, while Webb has revolutionized our ability to search, it also highlights the vastness of what we still don't know. It underscores the monumental effort required for definitive proof. It's a humbling realization. The universe is even more complex, even more subtle than we imagined. The journey to truly answer the question of life beyond Earth is not a sprint. It is an interstellar marathon, with Webb merely the first incredibly powerful stride. The tantalizing possibility remains, an elusive prize just beyond our immediate grasp. The future of astronomy, catalyzed by JWST, promises even more groundbreaking discoveries. Its mission is far from over. Upcoming observations will continue to push the boundaries of time, looking at even fainter, more distant galaxies. It will refine our understanding of galactic evolution, stellar formation, and the fundamental physics of the early universe. The deep fields it is producing are veritable cosmic archaeological sites, each one revealing new layers of history. We are effectively peeling back the layers of the universe's past, one ancient galaxy at a time. Webb's continued operation also sets the stage for the next generation of observatories. It serves as a vital trailblazer, proving technologies and informing the design of even more powerful telescopes in the future. Imagine a telescope even larger, with even greater sensitivity, perhaps built in space, or even on the far side of the moon, shielded from Earth's interference. The lessons learned from Webb are invaluable blueprints for humanity's continued quest to understand the cosmos. This is not the end of the story, it is merely the most thrilling chapter yet. The transformative potential of JWST for our understanding of the universe, and our place within it, is immeasurable. It has shown us a cosmos teeming with more galaxies than we ever conceived, a universe evolving at breathtaking speeds and countless worlds orbiting distant stars. It has sparked both scientific revolutions and profound philosophical contemplation. Are we truly alone in this unfathomable expanse, or are we just one tiny part of a much larger, grander cosmic tapestry? The sheer scale of the universe, now more visible than ever before, can be both exhilarating and terrifying. It forces us to confront our cosmic loneliness. To gaze at these ancient lights, traveling for billions of years, is to feel an almost unbearable sense of isolation. Yet, it also fosters a profound connection, a shared sense of wonder and humility. We are seeing what no human eye has ever seen. We are asking questions that echo through the ages. The universe, in its raw, unfiltered glory, is now laid bare before us, thanks to this golden eye. It challenges our anthropocentric view, reminding us that we are just a speck, yet a speck capable of reaching out and comprehending such immense beauty and complexity. But here is the ultimate, perhaps unsettling, truth that Webb is beginning to whisper. The universe is incredibly vast, incredibly old, and utterly indifferent to our existence. It is beautiful, yes, but also silent and uncaring. We see galaxies being ripped apart, stars exploding, worlds forming and dying in cosmic anonymity. While Webb searches for life, it also shows us a universe that, on the surface, appears empty and cold. Are we truly prepared for the possibility that the universe is teeming with life, and what that might mean for our unique identity? Or, perhaps even more profoundly, are we ready for the crushing silence of finding nothing at all, proving our cosmic solitude beyond a shadow of a doubt? The answers await in the light and the darkness that Webb continues to reveal. What will you do with these profound new cosmic truths?